Yeah.
All right, welcome everybody. I
o'clock.
hope you're in the right room. This is the ANIMA working group, and we're at IETF 112. So let's get started. IETF note well, I hope you're all aware of this, everything you're saying here, public, and there was actually another slide I should have added, but I couldn't find a good template. Please expose good behavior. There is the rules of conduct, that everybody should be aware of. I think we may want to resend that to the mailing list as well. Logistics, Sheng and I, you see the videos where the chairs. If you're presenting or when you're presenting, feel free to also use video. There is no need for it, but it's always nice to see each other's faces. The minute taking is really the most important thing here on the slide. I've seen working group chairs that let their working groups sit around for 10 minutes not doing anything until somebody who was willing to take notes was standing up. So do we have volunteers here?
Here.
Did I hear something?
I volunteer.
Oh, excellent. Thank you very much. All right. That moves us on the slide.
Yes.
Right. Early IPR disclosure process. Just as a reminder, we are asking for IPR disclosure also when adopting a document to the working group, not only when it is in last call, to avoid problems other working groups had in the past, with late disclosures from authors. All right, marketing. It's this time of year again. We've got the non-com period, which has finishing feedback by November 23rd. So if you have feedback about any of the people running for the various area director, IAB, and other leadership positions, please provide feedback to non-com in email. Of course, any type of general feedback can also be given through the same tool that is on the non-com webpage, the URL you see here, and bitch about anything you don't like in the IETF in the general section. Or, of course, kudos are taken as well. And obviously, this was brought to you because I happen to be randomly chosen to be on non-com this time. So, right, more marketing. So this is marketing for ANIMA that we did. So a bunch of the authors of the phase 1 ANIMA RFCs got together, and then after recycling the stuff for several times, we got it into the Internet Protocol Journal of October 2021, 17 pages of what we hope and what I do think is a really great overview of ANIMA and what can be done it really from the perspective of selling it to operators, users, and developers, including examples of ASA, and so things where we would like to have future work being brought into ANIMA. So please, take a look at it. And when you always had people who didn't know what ANIMA was, I think this is probably the best that you can point them to explain it to them. All right, and yeah, we've got RFCs now, and that also means that we likely should have and will get and do have erratas. And I think that's part of the IETF process that people are often missing. So especially when you're an implementer or you're reading RFC trying to catch up, please make sure that you're checking the errata so that you're not overlooking something which we already knew should have been fixed in the RFC, but it was too late. And of course, when you're discovering erratas, please simply go to that errata page and file an errata and basically go through the process of review. So yeah, we've got 3 of our RFCs with erratas, and so that's, I think, also a good show of the erratas getting read and or being implemented against. Right, so which brings us to actual work. The working group documents, the ASA guidelines, That document was up for quite a while, and so we had it passed through working group last call before IETF112 without further negative comments, and the shepherd pushed it through, and then we got all the IPR disclosures, and so I requested the publication to ISG today. So one thing to go into Robert's queue first, and then of course to IETF and ISG. For the Brewski Cloud, we don't have a slot today. The authors incorporated the IETF111 feedback and added security considerations. So they think it's ready for working group last call. So we would probably, we're going to do a working group last call after this IETF. So then the ANIMA constraint joint proxy. Yeah, we need a shepherd write-up. Working group last call finished. That was including an early IoT directorate review, so we already got some very good feedback from that. The latest version 05 should resolve all the issues, and I think we'll learn more in the slot about it. Brewski, asynchronous enroll will be talked about by the authors. There is a draft being split out from that, and so this time I'm not sure if how many here are remembering similar discussions we had when we started ANIMA, at which point in time we're kind of struck by not restructuring documents and, let's say, changing 140-page long documents into more smaller ones. So this time we had good experience reference from other working groups that that process is painless and can be done without going further back to the working group. So I was talking specifically with Russ Housley, who's the working group chair of LAMPS, and they've done exactly that, structuring into smaller, more manageable documents as well. And as long as those documents stay within the scope that was agreed by the working group for the larger document, then this is simply something that the working group chairs can agree on with the authors. Draft ANIMA constraint voucher, we've got a slot, JWS voucher. We've got no updates on graph distribution and ANIMA voucher delegation. Anybody from the authors wanting to stand up and give any information about these two drafts?
Actually, Terence, can you hear me?
Yep.
Yeah, it seems there are very long delay, 1 or 2 seconds. However, as author of the grasp distribution, actually we believe we have asked the working group last call from last meeting. So that's why there's no update. So I guess you missed that from July. So I will blame on you for this.
Okay, so I'm overloaded right now. So let's take that to email. So just make sure that we're not losing it. I wanted to take it to the notes here, but I see that Michael also didn't catch, I think, what you were saying. So maybe if you can simply add it to the notes so that we
it was ready for a working group last call. Is that what I heard you say, Sheng?
Yes, exactly. From July.
Right. So I think we got something like two documents where we need to run working group last call after the IETF. Okay. So now for all the documents that we're working on, we really need more document reviews. And so would really be good, first of all, to make sure that the reviews are tracked in the acknowledgement sections with all the names that had been done. The more detailed that is, the more it helps at the working group last call and ISG review later on. You know, don't wait for reviews in the last call, but reach out to other authors of other documents in the vicinity in Anima to ask them for review. If you have trouble getting more reviews by yourself, to reaching out to other working group participants, please reach out to the chairs, and we'll discuss it with you. There is also a formal part of the process for early reviews from other things, like we've done with IoT Directorate Review, which you know, could have been done before working group last call as well. There is review from a bunch of different formal languages, like especially Yang doctors, and also areas like early security review. So all of these reviews should, as much as possible, be done before we pass the document on to the ISG review, because the better it gets out of the working group, the better the working group also, you know, is perceived to have operated. So please, you know, start engaging as an author yourself to collect feedbacks and reviews from other people. And for the stuff where we as the working group chairs can or must help, please contact us. All right, which basically gets exactly to the point. If you're on the receiving end of this request, and you should be on the receiving end if you're an author, because you want others to review your document, so you need to review other people's document. And the best way to do that in a focused fashion is shepherding. So become shepherds for some other author's document. It's really about reciprocity, and it's been one of the old principles of, you know, the way the IETF works. It's one of the pieces that hasn't really been written down well, so it's not well formalized, but the IETF doesn't really work as at all without this. Let's see if we can, you know, get shepherds up. So you see the you know, the documents we're talking about, and I think each of the author can mention if they have a shepherd or not. And so if, you know, you want to step forward, become shepherd for one of the documents, please do so on the mic line. Otherwise, we're going to take it, of course, also after the meeting to the mailing list. Here's the list of the document that we currently have in the working group that are needing shepherds. So you know, if you're author of one of them and not one of the others, please really strongly consider now to become a shepherd for it. Otherwise, be sure I'm going to ask you in email afterwards. Okay, then of course also, do we never have enough time for technical discussions, and it's all, you know, a death by PowerPoint. The IETF has a lot of processes, and I think we're learning that many of them do help us to do the job better. Doing that, you know, for 2 hours 3 times a year isn't really that bad, but of course it's not enough to do all the technical work. So please, when you see that the work on documents can be done better, you know, start to become active as well, with the help of the working group chairs, of course, as always. You know, try to do something like a design team, just a 2 weekly or monthly meeting on, you know, you can use the WebEx from Anima. The working group chairs are happy to help, or also a lot of similar RTC web conferencing tools, so that you have audio video channels to much more quickly work with collaborators on the documents. Right, and the best example, of course, is the Brewski design team, which has been focusing on a good subset of the active working group documents for Brewski that we have here. The time had changed, and it's been going on very actively. So if you're interested in the Brewski aspects or so, this is basically the starting point where you want to go to. Of course, we also have a GitHub. That's not an official GitHub, but if you want to, it's not limited to working group documents. So any document you're writing for Anima, feel free to, you know, put that into that repository. If you're not on the repository, we'll be happy to invite you to it. And that's it. I haven't put the agenda here because kind of duplicating the stuff, the agenda between all the different places. So please go to the notes pages. The agenda is there. The first speaker, I think, should be Michael for the post-working group last call, constraint join proxy for bootstrapping protocols. Michael, it's all yours.
Ask to share slides. That's the one. Did that work? I think so.
Yep.
Okay, so
and I'm
we had a working group last call in October. We received a number of comments from that. And just to remind you, this is about having a stateless proxy for DTLS. That means that you don't need to use memory for each connection that you receive, and it replaces a stateful proxy, which is in Brewski there. So working group call ended. A working group last call ended on October 14th. We got reviews by Esco, Rusko, and Brian Carpenter, and a new revision was posted a couple weeks or so ago, just I think on the deadline. And mostly we did some restructuring of some of the introduction to make some of the pieces clearer, and a little bit of nits, and that's about it. There wasn't really any significant technical concern, although Esco did raise some issues that I think Peter and I said we're not going to solve those issues, and that was marked as such. And that's really it. So Peter has implementations of all of these pieces, and I think so does Esco have some pieces as well implemented. That's about it. Any questions?
Yeah, Michael. Do you have already addressed the comments from the IoT review?
Yes,
IoT directory
we did.
Review.
Yes, we did address the comments from the IoT director review.
Okay.
So that was Russ
great.
Housley gave us the IoT director review.
Good. Then that will be the action on me next. Allow me 2 weeks to do the rough check and the Sheffield writing. I will get back to your authors, ask for the IPR disclosure question as usual. Then give me 2 or 3 weeks for that.
Okay,
Thank you.
Great. I'll go on, Taurus.
Yeah, please.
I think the next
so.
item is, which one is it? Constrained voucher.
Number 3 is the constraint voucher, Brewski.
That is here. That is not the right document. Draft.
Oops.
Did I upload the wrong one? I bet I did.
Well, this is a bucket passing protocol across multiple stages. So
stop share. Let me see. I will stop sharing slides, and I will ask to share my screen, and I'll pull up the right PDF file really quickly here. And yes, I want to share my screen, and just give me 1 second here. Anima constrained voucher. Only guess that I pointed at the wrong document when I uploaded it. Sorry about that, folks.
I have the screen, but we have.
Yeah, I'm just gotta get it on my screen before I share it. There we go. Window, boom, click. Okay, better.
Here we are.
Yes, there we are.
Yep.
So just to remind you, there is also a bunch of there's now a brewski.org, and there's a bunch of implementation stuff, and I mentioned this last time, but I'm just going to mention this again anyway, just for the hell of it. So essentially, these are the changes that we've done in the constrained voucher document since IETF 111. We had a hackathon before that one, and we tried to have a bit of a hackathon before this one, but we really didn't. We didn't have a lot of participation, unfortunately. So essentially what we've done is the major things is that one of the things is this updates. So if you're familiar with the whole debate as to what does the updates word even mean? And so we both amend RFC 8995 and we extend 8995 and we extend 8366. So that is explained in that section. And then we have a bunch of little changes to the protocol, a lot of additional pieces. We discovered some problems with the SID values, some duplications in the previous draft. That's an oops, and relates to the renaming that we did, and we fixed that recently. And it may not be in the last version, but it is fixed now. One of the things that we were worried about is what to do if the Yang Seaboard documents that we depend upon did not advance, because they've been stuck in an ISG review since June-ish. So that's part of this. So I went and looked at that document and the issues, and I tried to reboot the effort to get it through, since if that document doesn't go through, then our document would not go through. And at the same time, what we also did is we said to ourselves, well, what would we need to do to make the references to it not normative, but rather informative? And so we have a pull request doing that we have not yet at this point merged. So we're basically hedging our bets here as to whether or not this document will advance. I went over to the core working group, read the comments, turned those comments into issues, and we seem to have a somewhat of a design team to fix the issues finished. And so 34 of those issues are now closed, and it looks like we could just continue on the way we were intending, depending on those documents, to see what's happening. And I swear I changed the footer on this thing. About the hackathon, so we did have some conversations last week. I at least didn't have any packets flowing or testing. We did several of us get the IETF hackathon L2 VPN working, and that lets us test the join proxy across the network. And I'll finally mention that there is an IoT onboarding thing that is finally active from the NIST and the NCCOE, and that's something we discussed last time as well. So there's a document that will tell you if you want to bring your product to there to have them play with it, then you can go through a letter of intent with that process. So that's another kind of interop stuff that's happening, and that's really about it. Yep.
Getting back to the hackathon, you mentioned not really any participation. Well, at least I was there doing something. So
yes, I was doing something, but we didn't interact, did we?
Well, not much, but my client interacted with your server. No, not your server, with your certificate. So maybe I can just briefly show that. I think that was also intended as part of the
so
right?
do you want to share something? Is that what you're saying? Or you want to just talk about it?
Yeah, maybe share the screen if I know how. Oh, yeah.
Yeah, go ahead.
I
need to stop by clicking on that part. So ESCO did report a bug to me, a big one, in the form of my certificates. And I haven't been able to fix it yet because I just haven't had a focus cycle to do that. So what do you have here?
Yeah, what I'm showing is the constraints pledge. So this is a USB stick format that I use. Just to show context. So it's a really small device with a 15.4 radio on it. But this was not the one I used last week during the hackathon. So we'll click that away. So for the hackathon, I actually had, maybe just show it here. Yeah, it's basically command line Java program that looks like this. So you start it up and get lots of
all too small for us to see, but it can see that something's happening.
Yeah, at least I can see it. I can read the text a little bit. You can make it a little bit larger. So, but it's just a testing client, so not constrained, but Java based, and also open source. So you can do request voucher here, for example, and you get a load of debugger messages, and in the end, it mentions failure. So it's the 4.0 error.
Yeah,
you can see here. So what was done is I also improved this diagnostic messaging so that the client will actually display the diagnostic from the server. So this is my own registrar server in this case. And the reason of the error is that the client was using Michael's certificate, so I downloaded that from basically his website. So I'll just show.
And they're wrong. They don't have the authorized key in thing. They have a subject key indicator, and so you couldn't build the IDEF ID, and so that's my bad. And of course, you know, if we don't interop, we don't discover these problems because I didn't do anything with that code yet.
Yeah, so you can see it. This is like the dump of the certificate. So you see the subject key identifier in there, and that should be here the authority key identifier. So that's the thing it's complaining about. And this is actually the first time I tried my client with your certificate. So that's the step I did. And for the rest, I also did not have much time, similar to Michael last week. So that's about it, but it's progress anyway. I think there was one minor issue here.
Only is this intended in you know ultimate deployments to use IPv4, or did you just do this because it makes troubleshooting all these logs easier than v6 addresses?
Yeah, I think that in this Java pledge, it will just use IPv4 or 6, whatever is available to the server. I think it actually should resolve to IPv6, to be honest. So I'm not sure where did you see IPv4?
Oh, the black line with all the small fonts, there were only v4 addresses in it.
Okay, you mean this?
Well, that's one of the problems that several people have is they're using Docker containers just deployed under AWS, and so they're reachable by v6, but because of Docker, they don't have v6 inside the container, and so they can't go out, and that's a major limitation with EC2 containers, and I don't know if anyone solved it, but
here I honestly don't know why it's using v4, because I actually put the DNS to only give back a v6 address, I think, normally, but okay, that's maybe good to check. And the constraint one only uses IPv6 in any case.
Okay.
Yep.
Thanks, Esko. I'm done.
Yeah.
I think we're out of time, probably.
Yes. I'm also done.
We're 10:20. Yeah, we're 10 minutes behind. I think that's we're reaching our wiggle room. So, Stefan, status of Brusky AE and derived work, please. And there he goes.
Right. Right. Okay, so you should see the slide.
Yep, please go ahead.
Okay, perfect. So as Tolas already mentioned in the overview, we went ahead and discussed during the last IETF the split of Brusky AE according to the use cases which were included there. So those use cases developed in different directions. So we thought it's better to have a split of the draft, to have the functionality contained, and be easier able to declare conformance to a specific functionality. So use case 1 stays as what was described as support for asynchronous enrollment in Brusky, and it basically relates to the using an alternative enrollment protocol other than the EST simple enroll that is specified in Brusky. So we are concentrating there on lightweight CMP usage specifically, and the focus is placed on the interaction between the pledge on one hand and the registrar on the other side, because from the registrar to the backend, it's also a matter of deployment what type of enrollment protocol is used there. So in the second document, use case 2 became Brusky with pledge in responder mode, or as Michael was already stating, Brusky prime for PRM. And it covers the use case where we have a reverse direction between in the communication between the pledge and the registrar. So that was the case where we introduced the registrar agent to facilitate the communication between the two. So just to go through both of the current drafts. So both drafts are available in the repository, and for both drafts we also have a GitHub on the Anima working group Git. So the status of Brusky AE So from version 02 to version 3, we did some housekeeping, addressed some of the open issues for the voucher young, for the young of the voucher request, and included some further open issues regarding the usage of the young models for getting the agent proximity into the voucher request. So that was related to use case 2. And the CSR encapsulation, we used the ZTP or SZTP submodule for that, and that was included also as an open issue in there. So from 3 to 4, we essentially did the split of the two documents. So everything that was related to use case 2 is now in Brusky PRM, and the remaining parts are contained now in Brusky AE, or are still in Brusky AE. So we also have some change of authors there. So David von Oheim, he is a co-author and will be the main editor for Brusky AE. He is currently engaged in doing a proof of concept of what has been described so far in Brusky AE. And I think that's very good to have that implementation background to be able to progress the draft. Thomas has left and will concentrate on the second draft, Brusky Prime. So next steps regarding AE is the clarification of the further open issues which we have stated in the draft. On the Anima GitHub, there is currently no open issue. So the ones that were related to the use case 2, we moved to the Brusky PRM repository. So the next step would also include to enhance the general description using alternative enrollment protocols and then concentrate on the lightweight CMP profile as stated, and maybe also on EST with full CMC. That is something we have to discuss further also with Elliot. I don't think that Elliot is participating today, but this is something we have on the list. So the updates, as usual, will be circulated, and also as usual, working group review is appreciated. And since I mentioned that David is currently engaged in the proof of concept implementation, there is obviously also interest from others that we can go ahead and make an interop testing in one of the next hackathons. So far for Brusky AE. Then jumping over to the second half of the original Brusky AE, Brusky PRM. So we contained all the use case 2 related issues in there for the pledge and responder mode. We included the issues that came up from the Young Doctor early review. So that was mainly some IETF voucher request enhancements that are reflected in section 6 that describes the Young model for Brusky PRM, and also within the security considerations. We also did some alignment with the naming of the IETF voucher request with other drafts in Anima, like the constraint voucher, for instance, to be able to list them accordingly. And then in the voucher exchanges, we now use the IETF voucher request PRM, which has the enhancement included for the agent signed data, which is one of the elements that is included by the registrar agent. And we also included the changes from netconf SZTP regarding the CSR types. So it's now a ZTP types included that allows us to use it without including any of the further types that are defined in the SZTP CSR draft from netconf. Regarding the next steps, so we need to further rework the draft, so adapt a little bit the structure of the draft and also the application examples, because there were just a couple of examples included, and we would like to enhance them further. And then we have some open issues which are also stated on the Anima Git and also in the draft. So one is to essentially verify that what is included now regarding the IETF ZTP types, which we use to convey the PKCS10 request, if that is defined in the right way. And then we have a further open issue regarding the generation of multiple CSRs. So the reason behind that is right now we are concentrating of bootstrapping a generic certificate, which can be utilized later on. If the pledge has already some knowledge about the deployment domain or about the applications that he requires a certificate for, then it might be useful to also be able to generate multiple CSRs that are then they're bootstrapped essentially during the or enrolled during the first round of Brusky PRM. Last but not least, we have also one open issue regarding the enrollment response object. Currently, this enrollment response just contains a certificate, the LDAF for the pledge. If we think those scenarios further, then we may end up in including additional information for either the certificate or also some further configuration data for the pledge. And when we do that, then we would for sure need a signature on the enrollment response, because currently we don't have a signature included because the LDAF is signed by itself. So also here, we circulate the outcome and also discussions on the mailing list, and working group review, as always, is appreciated. Thomas is currently engaged here in the POC implementation. So that also means that if there is interest from others for an interop testing, that would be great. Okay, that's about it. So in the backup, I've just included the call flows for the two Brusky splits, one for use case one, or one for Brusky AE and one for the Brusky Prime. Any question?
All right. Thank you very much.
All right.
And I think that would bring us to Thomas as the next one, update on JWS signed vouchers.
Yes, that's right. Hello, everybody. So I have to share the slides now. Where do we have it? So that's it. Share. So can you see it?
Yep.
So this is just a quick update on what happened in the JWS signed vouchers draft. So Michael and I working on that. So to recap what it is about, so the RFC 8366 specifies CMS signed JSON voucher artifacts, and here this draft proposes JWS JSON as another option. So it does not make any changes in the YANG, and so it can be used by the Brusky RFC 8995, and it also is used also for the Brusky Prime. Steffen just reported about that before. So what happened here? So what is the content? So we have two serialization options. So one for compact serialization, the other one for the JSON serialization. So first choice was to go for compact. So this is already implemented, so at least on my side, and considered in the draft. And there may be also interest in JSON serialization by OPC UA Foundation. So this is to be clarified and analyzed. So this is also on my list to double check with people from OPC. And if there is a need to have that, or if there is good reason to also support that option. So only small changes happened in that draft now from 00 to 01. So we in our consistent use of the terms pledge, voucher request, registrar voucher request, and the abbreviations of that. And so also the media types are fixed, and some terms were mixed up before. So consistent uses of JWS instead of JWT and COSE. So and some updates in the references. that's it mainly. And so next steps here is, yeah, I said already, investigate in the second serialization option for the JSON in the JWS, and yeah, circulate the outcome to the mailing list. Of course, feedback is always welcome here. Maybe if somebody would be interested to do the chat part, that would be also nice. So as Torles already asked for that. And also working group review would be appreciated here. And that's it. Any questions?
Yeah, thank you. Yeah, well, I mean, you always can offer being shepherd for somebody else and hope for reciprocity, right? So start offering, then you may receive back. So sorry for not being on top of all the workflows. I was wondering, is this, you know, the more variability in, you know, protocol options or encoding options, whatever we call it, we get, is this safe against, you know, poor operator in the end sitting there and not knowing why stuff isn't working? In terms of, let's say, a pledge supports some different encoding than the registrar. Are all the workflows such that, you know, a reasonably good diagnostic implementation of a registrar would always know not only that it didn't work because what was offered by the registrar wasn't supported by the pledge, but also what the pledge would support?
If this draft is agnostic, I think this has to be respected in the yeah, draft making use of it. So at the end, so this draft just defines the format or the form factor. So and other standardizations or other specifications making use of it, for example, the Brisky PRM, have to make sure that that no clashes can happen here, I would say.
Right, but I mean, when a voucher is being transmitted, is it kind of done with a request where, you know, the supported encodings are in there so that the registrar know which encoding, you know, would be feasible when it sends the voucher, or is that not
okay? Understood. So this is included in the content type header and in the accept header. So by the accept header, the pledge or also the registrar, if it requests a voucher from the MASA, can define or specify what it wants to receive.
Yeah, well, just an example, right? I mean, the more variability we get, you know, there are two concerns. One is so many drafts for the IETF, but the the other one is just making sure that you know, we may not get interoperability between everything, which is fine, but at least we should be able to always get the right diagnostic to not have the solution become undeployable.
That's right, and maybe something to add. So the default here is, so the idea is here by default, if nothing is specified in the headers, so then it replies back so what received in the request format. So if you receive a JWS signed voucher request, then the server replies with a JWS voucher. And if there is need to change the response, this can be addressed by the accept header.
Cool, thank you. Anybody else? Otherwise, I think we're back to Michael. Status of 8366 BIS effort.
Buttons. Let's hope this one is the right document. Oh, it is. How about the... Okay, so this primarily came out of the Brewski async enroll, who needed to have an additional value for the enumerated stuff. So we now have all these derivations from 8366. And it's been now 3 years since we published this document. So the problem was that we needed to do this enumerated type, and it turns out that we can't do this we can't just extend the Yang. It's not a way that we can do it because of the way we did it. But there is a different way, and Brewski async enroll would like to have a new assertion type. So normally the assertion type in Brewski is proximity. The two possibilities are logged, and the other one I always forget. But logged is essentially is used to make nonce ones, and the other one is used primarily in SRTP for that. And I can't remember what it's called now. It's lost in my brain. So the proposed resolution is that we're going to revise this document, and we're going to make this an enumerated part of an IANA managed registry. So we have to create that registry in the document, and then we have to reference it. And there's a mechanism in, or I'm not sure as a mechanism, as a procedure in the Yang community as how to do that. And so we're going to wind up with the numbers in the registry. And that should be just right. This shouldn't have any real effect on anyone coding, because we shouldn't actually be changing the resulting JSON or CBOR that's derived from this. In theory, will not change at all. So if you aren't using something new, then this will be a completely no change to any of the bits in the wire, but will accommodate new types of bits in the wire. If someone was generating something with a Yang code generator, then maybe there would be some difference. I don't know exactly. I presume they would not be. We would code it, so there would not be. So what have we done so far? The work to do. So we turned the document into an XML, put the new modern make files on top of it, pulled the Yang modules out nicely so they can be edited, and compare the text file to the existing thing. And that was kind of came up at the last meeting. So now we're going to have to revise the document and with what we need to change. And then we'll get around to asking for working group adoption. It's something I certainly could use help with. Don't have to be a co-author of the original document, I would say. But I don't expect to run through this very quickly. And I hope that it will get done fast enough so that Brewski async enroll will not be delayed, but I don't expect to get it done any faster than that. For that. So I'm still a bit unclear of how the working group feels about this. It might be worth having a consensus call or some other thing to ask the working group, what do you want to do? Is this really what you want to do? And I personally hadn't had any time to do it since work on it since IETF111. What I thought was that we would adopt it first, and then that would be the consensus that the working group wants to work on this problem, and then we would put the changes in, and the adopted document would be identical to the original one. But that's not how the working group chairs would like to work, so that's fine. We'll continue that. There might be some other things that need to be fixed in 8366. It is now, although it was published 3 years ago, it is probably more like 4 or 5 years since we really had a working group discussion about it. And one of the possibilities is whether or not we could go from proposed standard to internet standard in this same step, because we have a fair large amount of interoperability experience, and we're essentially fixing a bug in the document. We're not really actually changing anything on the document. So that's a possibility. Could we go to proposed internet standard step 2 at the same step? And I don't really know about. I don't know whether whether the changes would be too much or not enough, or what exactly. That's it for me.
I'm not quite sure about your comment about how the chairs wouldn't want to run it. So remind me what that was. But other than that, I think on your questions, I don't see any other options than doing this. This seems to be one of the pain costs of doing work with Yang, and if at all, I'd blame it on bad Yang doctor review that they didn't catch a non-extensible way to do something, which hopefully in 8366 we did mark well enough as something we wanted to extend.
We may not have articulated our needs correctly. It may be that the state of Yang 4 or 5 years ago was, oh, we didn't think of that. Okay, and now they have. So I think that's pretty part of it. One of the things that we could do in this revision, if it wasn't urgent, is we could go and collect all of the extensions from all the other documents, right? I don't know if that's a great idea, but we could do it, right? It's something that could happen. So I'm not sure exactly what to do that way. I think we shouldn't collect all the extensions into this document. That it'll be disruptive to those other documents. And there, if we were starting this work solely for the purpose of going to Internet Standard, then I would say that's probably is a good idea. We probably would have published several other documents already. And that may be argue why we shouldn't bother trying to do this step at this point. I don't know. It's nice to have Internet Standards rather than proposed standards.
But wait a second. So if we want to go for Internet Standard with this document, we should not add more functionality. The fact that we need to wiggle around with the way we do things in Yang is fine. Nobody will care about that. We need to have some, adoption.
Yeah, we're correcting bugs in the document. Yeah,
exactly, fixing bugs, and then I think we also need some, implementation experience document or so. We've done this in other working groups, so that would be a good thing, right? If we can show implementations interoperability, that I think would help us to do that. So certainly seems like the easier thing now to get on top of the Yang thing, because that may be something we want to do for other documents as well correctly, and then do the proposed the go to Internet Standard with it. That sounds like an achievable and useful goal.
That's all my comments. Maybe our area director has a comment on whether we can do that.
My hunch is you can, yes. I think as you say, I think to summarize this up well, as long as it's sort of bug fixes and things going in, I think that would be fine as far as I could see. There is a choice also to publish it as PS and then do a separate status change document, but it'd be better to do it in one go, I think.
Yeah, that kind of blew in the face of everybody with the beer documents that were all still marked as experimental in the original RFCs, and while they're not anymore, so people learned about that the status is not what the text of the document actually says. So
yes, that's frustrating.
Okay, thank you very much. If nobody else has comments, let's move on to slot number 7, autonomic IP address to access control group mapping. Yizhu, can you please step forward?
Let me find my slides. Okay, so I'm going to show this deck of slides. Basically, it is update to this ASA function called autonomic IP address to access control groups mapping. Let me see the next slide. This one is basically a recap of the basic idea from the last version. This is a very simple campus network. We have ASA deployed at the switches or routers. So the AAP here stands for Access Authentication Point, and PEP, as usual, is the Policy Enforcement Point. So we deploy the ASA here in order to pass around the information from the mapping information from the IP address or IP prefix to the access control group. So the motivation for this work is the group-based policy is becoming more and more commonly deployed, especially in campus network. So we would like this mapping information to be passed from the AAP to PEP. We want to define the new grasp objective. We call it IP address to access control groups. This is pretty long, but we couldn't figure out a shorter but still precise name for it. So this new objective is defined to carry this information. And also this objective is supposed to be used by an ASA. Similarly, we call this ASA, the name is IP address to access control groups. So this is the recap of the basic idea. We made some changes from the last version based on the feedback from mailing list and some offline discussions. First, we give a name to the essay, which uses this new defined objective, and we clarify the terms PEP and AAP. Basically, in the context of ANIMA, they are roles for ASA supporting. I mean, for ASA with the same objective. But how this roles is going to be supported, I think one of the remaining slides will show that. Also, we clarified the PEP node can also be the information provider, I mean the mapping information provider to the other PEP, because it's almost equivalently that conceptually this PEP is function as an AAP to the requesting PEP. So there are some other editorial changes, but for today's presentation, I'm going to show a few examples of how exactly this information will be passed around. This information passing around, basically, I don't think it will become part of the standard, but it would be informative for the readers to understand it. The most useful part for the standard, the standard part is most likely would be the information defined for the objective, which is already in the draft. So most likely the AAP will provide the mapping information to PEP. So there are two stages. The first one is discovery. The second one is negotiation. So the AAP will send the discovery and to find out the PEPs. Usually the number of PEPs is quite limited in a campus network. There might be only 2 of them or 3 maybe. So it will send the negotiation. The AAP will send the negotiation to try to push the information it knows about for the IP address and the group ID to all the PEPs. So basically, that's the most common and simple procedures to push the mapping information. And this slide shows the PEP asks for this mapping information from AAP. This is rare because in most of the cases, we think the AAP would voluntarily push the information to PEPs. So, but there could be some corner cases that PEP, there is no pre-stored information, mapping information on the PEP. So whenever PEP receives the first packet of flow, it has to ask for the AAP what's the mapping information for a particular IP address or IP prefix. So similarly, we have discovery stage, and instead of the negotiation, we have the synchronization message in the for this procedure. Okay, so next slides. This basically shows us an example of when a new PEP joins, what may happen. So when a new PEP joins, it tries to discover all the AAPs, because AAPs are the owners of the mapping information. So we're assuming that AAP will reply with all the information. Will reply the information it has. So the PEP will collect all the information from all the AAPs. So we gave 3 examples of how this grasp objective would be used. It's not an exhaustive list, but I think that should cover most of the cases. Besides that, after we uploaded the updated version, we're still receiving the comments from the list and also off the list. We will incorporate it into the draft. We're trying to. There are 3 major changes we're going to make. The first one is the conveying message. Originally, we want to use the unsolicited synchronization, but Brian pointed out it may not be ready for use, so we change it to the negotiation. This is basically to avoid the TCP long connection problem. And we want the second change we're going to make is to allow the discovery message in rapid mode. to be used in order to accelerate the procedures. Then the last one is, as I think the first or second page says, we have a role which basically it tells whether it is an AAP or is a PEP. So we are trying to use the objective name with the IP address to access control group .aap and .pep for multiplexing purpose. That's an easy fix and a quick fix for the function of role to work. Also, thanks to Brian to suggest this quick fix. So this is what we are going. We haven't, but we are going to incorporate to the next version. The next step is we'll revise the draft accordingly as we show in the previous page and upload it when the uploading channel reopens, or it's already reopened, I don't know. So they also would like to call for adoption for the next revision. We think it's pretty clear and ready for adoption. I think that's the last page. Yeah, that's the last page. So, any questions, comments, or suggestions to this document?
So the thing I'd really love to see, even if it's kind of, you know, maybe outside of the scope that you were intending to have, is, you know, a really an example of an actual service instance with the service parameters, so that somebody could build a prototype implementation of this that actually did something in an interoperable fashion. So I don't know what you kind of a real great example for such a service would be, because it's so abstract that I can't even circle in on you know, what type of QS that, you know, would most likely be a good first you know, first implementation or target. So I think that such an example would be great.
Okay, so maybe you want me answer this right now, or you want to somehow maybe put it to list?
Sure. I mean, I'm saying in the text, I would like to see the text extended
okay,
with an example section of showing, you know, here is how you would adopt this for a particular service, and that service is exactly named, whatever that QS thing is, the parameters of that, and then the graph stuff of it.
Okay, I see. Then that makes sense. Yeah, it's a little bit like an appendix, informative appendix. Try to elaborate more, right?
Yes.
Yeah.
But that appendix ultimately would, I think, also allow us to figure out, and I think that is the really important part toward this this spec, if or how we may need to create registries where actual services that want to get standardized would go in, and if we have services that are not standardized, right? So if we basically pick up the grasp stuff that is in here, we need to very precisely understand how application can use it in a proprietary and or standardized fashion, and that's where, you know, an example is really helpful to identify these extension points and then start for the grasp stuff here the same difficult discussion about IANA registries or, you know, other things to really be good about the extension points.
Yeah, I got you. Thank you.
Okay. Any other questions? I think then we're up to number 8, autonomic mechanism for resource-based network services auto deployment. Yujing, can you please step forward? Okay.
Okay. Yes. Okay, can you hear my screen? Okay.
Yep.
Can you see my screen?
Yeah, we can see your screen.
Oh, okay. Let's start. I'm Yujing speaking. Today I will presentation the draft on auto deployment mechanism for resource-based network service. And in the IETF111 journal start draft to discuss on auto deployment mechanism that deploys the resource-based network service through the ACP and by using Grasp. And this draft describes the negotiation between the resource required node to the resource provider node. And this draft want to describe how the ASA manages the resource in the network automatically. Okay. According to the mailing discussion, the new version will change a lot, and we summarize the major changes in the following modification. The first is that the draft sort out the definition of the network elements. And the second, the draft explains more details about the resource process with suggestion from the Brian and Michael, and it is the most important change in our draft. We made our process more clearly. And the third is that according to the resource process, we simplify the autonomic resource management objectives to make the negotiation more flexible, and some unuseful parameters will be deleted. First, we redefine some terminology, and the first we should emphasize is resource manager ASA. And resource manager ASA is a kind of autonomic server agents, and it manages the resources in the network. It is the most important part in our draft, and other we should emphasize is SI and APE and AS border router, and they play different roles in the auto deployment mechanism process, and both of them contain the resource manager ASA. On this page, we introduce how the two ASA manages the resource in the network. The resource manager ASA is often divided to the requesting resource manager ASA and providing resource manager ASA, and they communicate by using Grasp manager and through the ACP. And the auto deployment mechanism process includes three parts. The first is discovery part, and the next is resource negotiation part, and behavior after negotiation. And in the discovery part, resource manager ASA send a discovery message to discover other resource manager ASA, and it defines in the FC 8990. And in the resource negotiation, the resource manager ASA negotiation resource by using the resource manager Grasp objective. This objective we defined in our draft, and we will introduce the next page. And the resource negotiation may take place in several rounds, and in each round, requesting resource manager ASA can request more resource according to its requirements, and it will decide at each round how large resources they should to be offered. And as for the providing resource manager ASA, it responds how large resource they can offer, and they can offer to the requesting resource manager ASA. And in the behavior after negotiation part, we think the negotiation is ready, and the resource provider ASA should remove the accessible results from its resource pool and synchronization with other ASA in the domain by using grasp following message to tell other ASAs that this resource is used. There are two cases about how the ASA auto-deployment the resource. In the case 1, SI stands for the server initiator, need a resource to support their service. And SI will use this auto-deployment mechanism to negotiate with the APE to get resource to support their service. And in this case, SI will act as a grasp negotiation initiator. But if in a multiple network case, like in case 2, the APE should get resource from the ASBR before it responds to the SI. So the APE should send a waiting message to the SI to extend its timeout, and then the APE should negotiate with the resource with ASBR. Okay, and this page is about the update grasp objective. And this grasp objective, the name is resource manager, and it need to be added to the grasp objective name registry. And the loop count and objective flag we defined as in the grasp. We should emphasize that different for the resource type and resource value, different resource type we can request together. Okay, there are some questions we should discuss in the future. And the first is how to establish an auto-deployment mechanism to release or increase the resource when the server initiator change is needed. Another question is that if the two SSA are in a different domain, what are the rules they should follow? And about this question, Brian gave me some suggestions, and I will add this in the next version. The next step, we will plan to discuss some more open issue and update them in the next version. The last question is that whether do you think this is a useful word for Anima, and the draft is ready for co-adoption? Okay, that's all my thought. Thank you.
Thank you. Yeah, I think the same comment as on the last document, an example with really all the concrete parameters and everything, so that something could be implemented to actually show how this would work in reality would help, I think, a lot of reviewers and other working group members to better understand it and comment on it. Michael.
So about the cross domain question, we had a lot of conversation about building ACPs across domains at some point, and I think it's really important to understand what is the use case for this, to understand what is the appropriate trust for that. And it might be that this is a case for needing authentication in grasp, or it might be that this is a case for actually, I think your diagram kind of hints at this here, that to go cross domain, that we somehow create some ASAs that do this application layer stuff between the two of them. But I think that what is the right answer depends upon what it is that you're doing. And I think that we need some examples. And maybe it doesn't apply for all things. Maybe the same answer doesn't apply for all things. So that's what I would ask is that be called out a little bit more clearly in the document. What is the example for the cross-domain scenario?
Okay, I will think about this question, and I think in this draft we want to discuss negotiation process, and we think there are the scenario in the different domain. They will have some program about security. But I security. But I think this is shouldn't discuss in our draft. But I will think this more detailedly, and we can discuss in the mailing list.
Okay, that would be great. I'm just saying that I think that before you go to the effort of explaining how to do this cross-domain, tell me why would I ever want to do that? Why would I ever want to deploy a resource across this? And I think that we need some real concrete things to say what they are for that. And you know, I can think of some like optical paths or other layer 2 VPNs or something that have to cross multiple providers or something like this. But I think that needs to have some, like the word domain shows up 14 times in your document, but only 2 times with cross domain, and it never explains why. So that's what I'm asking. So before you solve that hard problem, ask yourself if it needs to be solved, is what I'm trying to ask.
Okay,
Michael,
I know it.
Michael, allow me to answer you as a co-author for this draft. First of all, we are not going to solve that in this draft. That's out of scope because for all those efforts we had in ANIMA, we are actually limit ourselves in a single domain. So that's why the brand suggestion said, you know, it's to be separate into 2 domains. And but we do have the use case in the real world. We need the cross-domain coordination, mostly for the end-to-end quality guarantees. If you only can guarantee one, because if there are cross-domain paths from end-to-end paths, if you have only resource reserved in one domain, in another domain, you actually has the another part of this path for the best efforts. Then that means whatever you have on the one single domain with whatever resource you have, you may waste that because in another domain, the latency or whatever the quality may get damaged by the best efforts. So we do need the cooperation. But again, that's not the purpose of our draft. Our draft actually focus on, solve that in single domain, and how to cooperation cross-domain. That's another issue. So we have to have this single domain solved first, right?
I think I'm saying exactly that. I'm saying, why are you introducing the question of cross-domain if?
Yeah, point taken. So we will clarify that in the draft. Thanks.
All right. Any more questions? Okay, then I think I'll be the next speaker. All right, so this is about the 2 drafts that I already presented on IETF112. So the Graph DNS SD and the Anima Services DNS autoconfig. Just wanted to quickly explain what we again what they're about and where we stand. So the DNS draft wasn't updated since 1.11, and it's a specification to support the equivalent of the DNS SD service announcement and discoveries, with even better service selection parameters through GRASP. Equivalent means it's not any encoding of DNS resource records or MDNS packet headers or so into GRASP, but really only the encoding of the API parameters like service name, service weight, service sharing, all those, and the addresses. And so these service parameters, which have very convoluted encoding into DNS resource records, these service records have a very simple encoding into GRASP objectives, and that's what this draft does. And what this allows us to do is applications that are written in the expectation that they're doing service discovery through DNS SD, that they could do it equivalently, if not better, through this protocol's GRASP API with the same parameters. And we would also be able to share any of the service registries and operational procedures. And ultimately, we could have, also implementations automatically select GRASP when it goes across the ACP, or DNS SD if it doesn't go across the ACP. So I hope a very fundamental good way to provide the most important step of self-auto-configuration of ASAs. And the second document, also we didn't update it since IETF 111, but just to re-summarize again, that was actually the driver to do the first document. And that's really the minimum amount of self-auto-configuration of services that we need to bring the ANI infrastructure up to a place where the most likely shortest term deployments will be able to use it. And those deployments would be the ones that we described in RFC 8368, which is the ANI together with SDN controllers. And so we're basically talking about everything the SDN controller shouldn't touch, so that the SDN controller actually has reliable connectivity across the whole ANI without being able to break it. And that particularly means that we need to have syslog for diagnostics. We need to have NTP so that our certificates are even working across all the devices, because we have good enough time synchronization, radius and diameter in SSH, so that the SDN controller can actually connect, for CLI or Yang netconf operations into the devices. So this is kind of the most core infrastructure services, and that should ultimately really round up a first round of ANI that can be usefully deployed. So really, I want to ask for the working group for adoption to this. So this should get on the list for adoption call by the working group chairs. All right. Any questions?
Curtis.
Yep.
With my chair hat on, I want to ask you, is there any reason you cannot merge these two drafts into one?
I think that is logically quite illogical, right? Because these services that we're talking here about, they're really very specific to ANI networks, as I imagine them to be used short term with RFC 8388, and the GRASP stuff is very generic, applicable to all the other uses of ASA and automatic functions. And so one is defining a protocol, and so this I think you'd be asking me, why wouldn't we have done DNS SD RFCs together with a bunch of applications using DNS SD together in a single RFC?
Got you. But
Okay.
Yeah.
All right. So Michael, do you want to say something to slot 10? You said no slides. You want to step to the microphone, or we want to skip that slot?
I'll just say that the documents aren't dead. That there is some work on the derived document about IDEV ID considerations in the T2T RG, but that I'm not receiving a lot of feedback that says these are terribly useful documents. So if you disagree, that would be great. That's about it.
Yeah, I would think that we just don't have enough operators that are complaining about the specifications not being sufficient to have sane deployment models. So I think we'll just may need to wait and let them linger on until we get closer to that point. All right, then we're to the slot 11, requirement and reference model of the L2ACP based ANI draft from Zhu Yujing. Please step forward.
Okay, show me my control and share my screen.
Yeah, you simply need to click on that icon on the right of the hand.
Oh,
And
okay.
then you get permission, and then you select a random slide deck and present to that. Now, please select your slide.
Yeah, yes. Okay.
Oh.
Okay, now I will
actually
present.
Screen share, which is fine. We had one presenter and before doing the same thing. So typically it's for all the participants, unless your slides have animations or so. It's easier for all participants to see the pre-shared slides. But please go ahead. Just wanted to make the note.
Okay. I will presentation the draft recommends and the reference model of layer 2 basic ANI. And this document we want to discuss the scenarios and the requirements of layer 2 ACP, and it is an instance of generalized ACP to implement part of ANI function in the layer 2 network. And it shows a reference model to construct such layer 2 ACP and the related function. On the first page, we want to talk about a little bit about background and some idea about the draft. So ACP is an autonomy to control plane, and it is self-managing and as independent as possible of configuration control plane. And we can say that current ACP implementation use IPv6 linked local addresses based ACP kernel. So we can say and say that current ACP is a layer 3 control plane, and however there are some cases that we think required layer 2 ACP functions. And here this picture shows some cases which require the layer 2 ACP functions. The Shoho and SMB case is a typically example. And in this case, we can find some one or more following features. So first is that the network is not very large. The number of hosts is usually less than 200. And the second, the network contains different type of equipment. Some layer 2 switches, layer 3 routers, and hybrid layer 2 and layer 3 switches. And we think they have a multi-level layer 2 topology network. So how to control this multi-level network was discussion. And the third, we think some nodes have fewer resources in the network like some IoT nodes. The last, we think that the network is sometimes required to firstly form a local area network disconnected from the internet. so that above all, we think that autonomous network management with layer 2 network nodes is required. Above all, we summarize the scenarios requiring layer 2 ACP. So one is that the manager network is a small layer 2 network where the network nodes have no layer 3 physical interface and have fewer resource. And the other is network manager would like to use and verify the layer 2 topology and reachability first for some major purpose. Because sometimes some ports can not have IP addresses, so we should use a layer 2 topology to control this. Based on the layer 2 scenarios, we propose some layer 2 requirements. We write on this 9 points. The first is that we think the IP addresses of the node and its interface may not be available upfront. And we thought the current ACP cannot suitable for this situation. And the second, we think that layer 2 ACP construction can be used on the layer 2 available information and mechanisms such as MAC addresses, VLAN or physical port information. Three, we think that adjacent node discovery should be carried as a layer 2 frame. And the fourth, we think it desire to reuse the grasp message as much as possible. The next is that we think layer 2 ACP should provide API to the upper layer to allow the ASA to invoke layer 2 basic function. And physical connectivity and topology information should be able to connect it with the layer 2 ACP. And next, the routing in the layer 2 ACP should support layer 2 loop-free logical topology creation and minimal manual configuration is required. The last is that we think reuse exciting multitask MAC address is desired. This is the requirements we thought the layer 2 ACP should have, and maybe this is not very complete. And this picture we show the reference model to layer 2 ACP, and for the reference model, we think that the conceptual API should allow the ASA to communicate with other ASAs by invoking a set of layer 2 transport basic function. And the layer 2 ACP provides a similar function as layer 3. See that in the picture. And the layer 2 ACP should provide like discovery, negotiation, and synchronization. And we think they are the same like the layer 3 ACP. About the conclusion, we think that there have some scenarios require layer 2 ACP, and we hope that we think this is an important topic in the ANIMA, and we want to find a way to define the layer 2 ACP. And the second is that the layer 2 ACP we discussed in our draft is to build a layer 2 basic ACP rather than ACP on layer port. So we think that we should must to face some situations that the interface have no IP addresses. So maybe we can use MAC address. About others like security consideration, I think if the network is not very large, we can take some physical way to protect our network. And but actually, I think this is not complete, and we think we need a further discussion. Okay, the next step we think we should talk about more about layer 2 ACP, and I think this should be discussed more clearly. Okay, that's all my thought. Thank you.
Thank you. Maybe question from my side. So in the layer 3 ACP, the very simple process from receiving a packet into the ACP on one interface, routing it at layer 3 and sending it out has just a very few steps, right? So you're receiving a packet on a link local IPv6 address. You're, let's say, decrypting it with IPv6, with IPsec, and then you've got an ACP IPv6 packet. You're routing that. It is routed from the Ripple routing protocol, and on the outgoing interface, you do the reverse thing. You're encapsulating it, protecting it with IPv6, and sending it out link local to the next hop. So can you explain for your solution how the same process would work? What are the steps for receiving, for such a layer 2 ACP node, a packet, forwarding it by whatever mean, and sending it out? I didn't see that really down to that level in the slides.
I think in the draft we talk about the scenarios and requirements, and I haven't considered your question very details.
Right. So I think that would be the first step in terms of please define a standard. Doesn't have to be the only one, but one case of how you think the forwarding should be able to work, right? When the packet is received, and what address is it received? Is it a layer 2 address, a layer 3 address? How is it basically, is it protected? And then when after the protection is removed, right? So yada, yada, these steps. So step by step, that forwarding, so that we can even start comparing your proposed solution with what the ACP today does. Does that make sense?
I don't have a sense about this question.
Right, but I mean, without an example of that, I think it's impossible for anybody to implement something that could be used as a reference example of the draft, right? So that's why I think being able to have that understanding from the draft is very important.
Okay.
Michael?
Back to your slide, I think it's 3, the LCP L2 ACP case. Can you hear me?
Pardon.
3.
This page or this page?
One more, I think.
This?
No, more. The first diagram, that one, yeah. So I'm trying to understand this use case. So we do ACP work over to talk to some management interface. And you said that none of these devices, this L2 aggregation switch, this L2 access switch, and the Wi-Fi access switch, none of these have layer 3 addresses. They don't get managed. They don't do SNMP. They don't do netconf. They don't do restconf. They don't do HTTPS. Is that what you're telling me?
I think sometimes this use MAC address is enough, and sometimes I think favor resource lead to this question.
Okay. I'm just asking because it sounds to me like they don't need to be managed. And so they don't need an ACP if they don't have any management interfaces that they need to talk to.
Chiming a little bit.
Yeah.
Yeah,
Go
this
ahead.
is Yijo. Yeah, I think for sure they are going to have management interface. Almost every equipment in current days, they have a management interface. But here it's more like it's talking about what happened before this equipment being enrolled. So it have the management interface after it gets enrolled. And if it is in IPv4 world, of course, let's leave v6 maybe for a little while. If it is in a v4 world, this management interface still need to do the DHCP request to ask for an IP address to be configured. So that's happened after the something like the layer 2 loop-free topology build up, and
Yeah.
everything being done, then it asks for the DHCP, send the DHCP request. So that's a step-by-step thing. So
Okay. So
it's not available at the step 1.
Do you think you want to change that? Because it sounds like it works fine now. So why change it?
What change what?
Well, like we've created an ACP specifically so that you don't have to do a DHCP request and set up your layer 2 before you can do enrollment and do all that stuff. We went to a fairly reasonable effort to have joint proxies, to have a whole bunch of other things so that we can onboard devices even though they don't have connectivity, even at layer 2 or 3. So we've done all of that in our RFCs, and we did that specifically because the layer 2 auto configuration just didn't work. We couldn't do DHCP, and so you're telling me I want to do DHCP. I'm like, well, okay, if you have a situation where layer 2 works and you can do DHCP, then I don't know why you need an ACP, right? So you're telling me you can't do onboarding until you have an address, or you can't have an address until you do onboarding. I'm not sure which one you said, but I'm just not finding this scenario here credible to me. Okay, I think that all of those machines have layer 3 addresses or have layer 3 stacks. I think what's missing is that you're trying to do some layer 2 tricks to avoid writing any code at layer 3. And to a large extent, I think that's what this working group is trying to get away from, the same way that we're trying to get away from dial-up modems attached to switches as out-of-band access. So I just don't understand what the scenario here is, right? What is going to happen to these devices? How are they going to be managed over a layer 2 network and they don't have a layer 3 address, which is, we've been told in a couple of slides, they don't have a layer 3 address. So you're telling me they do have layer 3 addresses, just not at that time. And so it sounds to me like really, I don't know, you have a problem where you have to solve it at layer 2 because the people that own layer 3 won't change their code, and so you have to change it at some other layer instead. It doesn't sound like a problem that sounds like a people management problem, a human resources problem, not a network management problem, right?
Can we maybe consider that we're going over right now to the slot number 11 of the whole discussion, because I think for your contention I would have answers which I'm not sure are actually what the draft here is proposing, but which would, I think, exactly answer why we would benefit from some form of layer 2 ACP, exactly for an example topology like this. So you said we don't want to have DHCP. That's fine. So we can do this case here where, let's say, all the egg switches, the access switches, and the access points, of course, are in the data plane, only layer 2 switches. Let's assume that, right? The core router is the only router. Everything else should in the data plane be just layer 2 switches. So with the current RFC 8994, we can do that, but it means that for the ACP, we're really creating layer 3 interfaces, which are not in the data plane, which are, just for the data plane, they're just, link local for the encapsulation on the bridge groups, and we separate the bridge group for the ACP traffic, and then we do all the routing. And if these are real hardware switches with fast throughput, only layer 2, then the ACP will be very slow. That may be sufficient for some deployments, but as soon as you're starting all the cool new stuff, like a lot of telemetry and firmware download and everything else, it would really be good that for the aggregation and the access switches that all the traffic, even for the ACP, would not have to be forwarded by them in software, right? So traffic from the core router to an access switch going through an aggregation switch shouldn't go through the CPU of the aggregation switch, even when it's in the ACP. So that is the limitation.
So I think, Torlis, you're arguing for MACsec, right? Or some other technology at layer 2 to do the forwarding.
I haven't talked about the solution. I've talked about
But I agree
the
with
problem.
you. I agree with you. It would be nice to do something else, and I agree that we can create a layer 2 mechanism to transport data. But I'm not sure that requires that we create a discovery mechanism at layer 2 or a mechanism to transport grasp at layer 2. Because as far as I can tell, all of those devices, you're removing the forwarding requirement from layer 3, but I don't see why the control plane that's going to receive and send grasp messages and other things, why that has to be layer 2. It means to me it could be layer 3 just as easily. And if you want to run our normal protocols, they pretty much need to be layer 3, don't they? Do we have a way to run netconf over layer 2?
I think this what you're saying and asking now is a little bit too theoretically for me, right? Because I'm thinking about the practical different options that we have. And I think 2 or 3 IETFs ago, we also had a little bit of time and I was trying to explain what I think would be the most easy solution to make these layer 2 switches work well. And that is, as far as the ACP is concerned, they wouldn't be routers, but they would be hosts, right? So they wouldn't
They're hosts on this
any
network, on this L2 network. Yep.
So we would need to depend on the underlying data plane spanning tree bridging, and we can of course think about how the ACP may help to further protect it or so, what tricks we can play. But otherwise, we use the layer 2 hardware forwarding plane, and all these hosts just use the normal ACP, but we may need to build a full mesh of host-to-host connections, so there would be no routing across any of them. And that I think would be a worthwhile effort and would create a single ACP with mixed layer 2 and layer 3 switches and give us a good solution. And unfortunately, I never had the time so far to write that down.
It could be that they negotiate, VLAN 4995 or something like this.
Yes.
They apply MACsec to it, and they all look like they're hosts doing, DHCP or ND or whatever on it.
Right.
And that's all. And I don't have a problem with that. We just need to be able to negotiate that clearly with grasp. It's just a new transport, right? We have IPsec and we have DTLS, and we'll have MACsec or VPN or VLAN or something like that.
Yeah, I mean, we would certainly love to use a separate VLAN for isolating the ACP traffic from the data plane. But as far as the crypto is concerned, could still be IPsec. It's just then IPsec from a hardware IPsec capable core router all the way to each of the layer 2 devices there. Yeah.
Over that spanning tree managed VLAN.
Yeah.
Okay.
Yeah. I mean, I'm just saying we should select the crypto for the maximum interoperability and performance and whatever the core factors are, right? So the question is, do we need any new crypto? And the big reason why I liked MACsec and still do like MACsec is when we really have these cool layer 2 plus layer 3 switches that can do layer 2 and layer 3 at line rate in hardware forwarding and also have MACsec hardware forwarding. So that is then faster than IPsec and software, right? So if we have something that's faster than IPsec, we should use it, independent of whether it's done at layer 2 or layer 3. But so far, I think the starting point to me after, revisiting MACsec after 6-7 years is it hasn't trickled into all the switches, unfortunately. That was the hope a long time ago, but it still seems to be for few high-end switches only.
But if you can do IPsec and software for the traffic, for your own traffic only,
exactly,
or the Wi-Fi access switch, if it's running slowly because it's downloading a new firmware update, well, that's just life, right? But while it's doing that, it's not actually screwing up the forwarding of traffic for anybody else.
Yes. Yes.
And I agree with you. That would be really good to do. I still worry about spanning tree in a scenario like this, because there will be dead links. And anyone who has tried to apply spanning tree, for instance, to VoIP, it's a disaster. You can't do it. It doesn't recover fast enough. You need to use OSPF or even ISIS.
I'm not sure about that. So I mean, yeah, I'm aware of
the
big
lockdown
service
timers are
provider
too long,
broadband.
even with rapid. You can get down to 1 or 2 seconds to redo a link, but OSPF keeps all the links open, and so as soon as you lose a link, you know within milliseconds, and you redirect the packets, right?
That's true. But I mean, our Ripple profile is also not optimized for very fast convergence speed, but for low load that we can support large networks. So I think that's perfectly fine that we're not getting better.
But the point about not using spanning tree is that the whole network's not using spanning tree, because the whole network can't tolerate those numbers, right? And that's why it's been turned off. That's why they've gone to an SDN solution that can redirect it instantly, or to some other technology that can do it.
Well, there are a lot of service provider access networks from the DSLAM to the core, which are using layer 2. So figure that, right? So maybe the voice over IP does sometimes have, a 1 second interruption from, the rapid spanning tree.
Well, if they do, then they get the customer changes ISPs. I've experienced with that.
If they have a choice,
it's not an acceptable. It's not an acceptable situation, and why quite a number of VoIP ISPs, for instance, they now own access networks because of that. The business customers won't tolerate that kind of thing. But back to our point is that it's that the reason why the STP might be off, in my opinion, is for other reasons, and they don't want to turn it on for to make this scenario work, and that's why there's a desire not to have anything that requires broadcasts to work, because until the devices are connected to their SDN, the broadcasts are dangerous. Right.
But I don't see a solution in which you're turning off spanning tree and have layer 2 only devices in a redundant topology.
That's what I'm saying. I don't see the point in doing that, right? If you're turning off spanning tree, it's because you want to turn all of those links into layer 3 links, and you don't want to try to do the whole thing, and so you're going to have layer 3 anyway.
And so anyway, then I don't think
too bad Brian's not here to talk about this, because he's done some things. And I one of the conclusions I had in the document that I did on a layer 2 discovery was that I finally realized that we could do layer 2 discovery over LLDP, for instance, even as originally thought of, but that once we get going, the ACP traffic would be simple unicast layer 2 traffic from host to host. And so it's not vulnerable to broadcast problems, and you just need to suppress neighbor discovery.
Also, I think in summary from my side, there is, a business case or there is an ACP use case we haven't solved for with good performance for layer 2 only switches in networks where layer 2 only switches are used. I think they're easy enough to build solutions for that. Whether or not that really is a good solution for a broadband access network, because it may not have good voice over IP, is an interesting question. But we do know that there are a lot of networks that are only using layer 2 switches in these spaces for whatever reasons.
What's our conclusion, Mr. Other Co-Chair?
Well, so I think
what do we do with all of this stuff?
Well, so first for this draft, I think we have the ask to the authors that I raised how they are looking at the forwarding plane, and hopefully from the discussion we had, they also have an idea on how to position their proposal to the use case. Hopefully the explanation of how the layer 3 ACP today works with existing layer 2 switches and software is also there. So what I was saying is something that we just need to find time to write down as a proposal into the layer 2 ACP case, and maybe we can create ultimately some joint document to go forward with. You have a write-up as well, right? And so there are many aspects in all of this. All right, are we at the finish of this slot? Any more questions to it? All right, Cheng, do you want to close the working group meeting? I think we run out of agenda.
Sure. Yes, we have done very good discussion here, and of course we don't have enough time to discuss everything as usual. So we should have continue our discussion in the mailing list. And from this meeting, the chairs will have to do some homework and also do the Schaefer work. And there may be some working group calls for the adoption we saw some potential here. Robert, do you want?
Once you're finished, Shane, are you done?
I have done.
Yeah, I was just going to quickly pick up on some of the points that Turles made early on in the meeting about sort of process thing. I would like to encourage folks to sort of cross-review each other's documents. That helps them progress a lot more quickly, because then you get comments and also you're helping review other comments. The shepherding role that Turles mentioned again, I'd like to encourage folks to do that. It's a really great way to learn what the sort of document publishing life cycle is and what the steps are, and it gives you a great view as to what that is, and helps you when you're progressing your own documents if you understand what the steps are and what's expected and required, those different things. So I'm sure that the chairs, for people who are new, would help you with getting started, and there's various guidelines, and I can provide some help and pointers for that. And then the last thing that Turles also mentioned that I think is really important, I'm really glad to see the slide, is about if you can provide non-com feedback on all the people you know and the positions and things. I think that's really helpful for non-com to make the decisions they need to and choose the right people going forward. So again, I think that's a good call out, and I support that as well. Thank you all for your time.
Thank you, Robert. Thank you all for your time. I'm now announce the meeting close. Thank you. See you next time.
Bye.
Bye.
Thank you. Bye.